let's talk about troubleshooting in TwinGate and where you should start and what are ways in the admin console and in the client to troubleshoot connectivity issues. So before trying to troubleshoot anything on the connector side, one thing you should check is that the client of the user is operating properly. And in fact, there's two types of issues. There's issues that are user-centric, where a single user is somehow unable to either authenticate or connect to a resource. And then there are resource-centric issues where, for instance, none of the users are able to resolve a resource or connect to a resource. So it all starts with a client. So it's usually a good idea to make sure that on the client, the user can connect to their TwinGate client and can authenticate. So the first thing to check is to make sure that the user in question can connect to their TwinGate clients. This brings up the authentication here, so we're gonna sign in with the IDP. I'm authenticated. Second thing to check here is that they don't get an error message, but that they get the list, a list of resources in their TwinGate console. The list of resources is retrieved only if a user is able to authenticate against TwinGate and fulfill the minimum authentication requirements. And if that's the case, the client should be able to retrieve a list of resources. And then you can start thinking about whether it's a user-centric issue or a resource-centric issue. Is one or more users unable to, is this user unable to authenticate against TwinGate or reach a single resource? Or is the problem that none of the users have access to a given resource? One thing to check here is that if your user is trying to access a resource, the resource actually does show up in the client. And remember that the way you declare resources in TwinGate entirely determines how a user is going to connect to that resource. So you see a lot of fully qualified domain name type resources here, station star.twindemo.int. There's not a lot of IP based resources. So if, for instance, our user was trying to connect to a single IP address, there's a good chance that, well, they couldn't because it's not declared as a resource. So make sure that whatever resource they're trying to connect to, how they're trying to connect to, exists as a resource in their client. If it's an IP, it should exist as an IP. If it's a fully qualified domain name, there should be a resource able to capture the fully qualified domain name traffic for it. If that's the case, if your user is able to authenticate against TwinGate, and your user can see the resource in TwinGate, then you can turn to the admin console because you have satisfied the prerequisites of verifying the client is up and running and can connect to TwinGate. So if the problem is isolated to a single user, one thing you could do is you can go to the user in question. So if I go to Teams here and select, say, my own user, this one, by clicking on my user, I will be able to see lots of information. I will be able to see the list of resources that I have access to, although that should match exactly what the user sees in the client. But more importantly here, you will see how a user's devices are configured. Now, one thing that's interesting on this particular user is that they have a client that is online, that's marked as connected, that is installed on the MacBook Pro, and if you hover over it, you will be able to see the client version number, make sure that's not out of date. You'll be able to see what verified or what trusted profiles and verification and posture check the device fulfills. But a good indication, for instance, here that if I had a device or a problem with a user trying to connect, it could be something about the profiles that are implemented against this device. But one thing that you can check on top of this for this particular user is the list of recent activities that they've had. So this will report every IP or fully qualified domain name corresponding to resources that a user has connected to. What you see here is not the actual resource name. This is where people actually connect. The resource name or the resource definition is usually in the definition of the event itself, so you can unfold every event and see quite a lot of detail. So you see where the user connected, from what public IP they connected, what protocol they used, whether the communication was peer-to-peer or relayed. You see the flow of connection from the client connecting to the connector receiving a request that it needs to connect to app.frontapp.com, and then a DNS lookup from the connector that was also successful, and then the connection was established and then closed. You can see the device that connected. Again, you can see the resource and resource definition, star.frontapp.com in this case, the port used, how long the session was, and what connector and remote network routed traffic. So if everything is green here, there's very little to do, but one thing that you can see is if you have, let's pick another user, one of my teammate, Ben. Let's take a look at Ben's user. Ben belongs to lots of groups, and Ben has a couple of errors in there. So Ben tried to connect to a server that is a resource, 10.0.07. It's actually called Twin Server RDP. So it's assumed that it's a Windows server. He's tried to RDP against that's hosted on Azure because it's in the Azure remote network. If I take a look here, so we can see right off the bat that it is indeed an RDP connection because it's on port 3389, which is the default RDP port over TCP. That's good. And so that would be something to check, right? If you see a connection event here that fails, then it's very likely that in this case, the problem is between the connector and the server in question. So you could have a connectivity issue in terms of routing from the connector to the resource, but it could also be a fully qualified domain name resolution issue. Now you'll see there's a difference between an event that goes to an IP address and an event that goes to a fully qualified domain name. You'll actually see an extra DNS lookup in the fully qualified domain name version of an event. And that is because the resolution in TwinGate is effectively done at connector level. And so if your connector is unable to resolve the IP address corresponding to the fully qualified domain name, the DNS lookup will be unsuccessful. And that is a perfect indication that you need to make sure that your connector can resolve all of your fully qualified domain name resources, right? So you could do this on a per user base like I did here, but the same thing is available on a resource base. If you have a particular resource that, let's take a look at 10.0.0.7 actually, and take a look at this particular resource and see, well, it turns out that it's not just Ben that's been having issues connecting to it. There's also another person that's been having an issue. So maybe there's something to check in terms of the routing between the connector and that box to make sure that the connector always has access to the box and can broker connections for all clients that have legitimate access to this particular IP address in this particular server. Now, here's what you should really think about, right? So if a user is connected to TwinGate, their client is on, they see the list of resources, but they can't access a particular resource at an IP address. Again, make sure the address itself is either declared as a resource or part of a resource declared as a site or range covering that IP address, because that is going to inform what traffic gets intercepted. Now, if you see the resource in their client, make sure that they're actually connecting using the IP address and not the fully qualified domain name. If you have a resource for a.b.c.d, but a.b.c.d also maps to a fully qualified domain name, but you don't have a resource for the fully qualified domain name, the client will not be able to connect using the fully qualified domain name. So sometimes what we see is miscommunication where a user is aware that they have the resource on their client, the resource is an IP, and they think they're going to be able to connect to the server using its host name. Not the case unless there's a resource for that host name and or fully qualified domain name. If all that's in place, if the user is connecting using the IP address, they see the IP address in their client, then very likely the culprit's going to be between the connector and the actual server. And so one thing you should check is actually the events that we just checked in the admin console for that resource, and check whether the traffic is routed, one, to the right remote network and right connector. And if the connector that's handling the traffic has access to the server. The best way to do this is, depending on how your connector is deployed, you can connect to the host where the connector is deployed and simply try to ping telnet the asset directly from the connector to make sure the route's open. That's always a good idea. And the third thing you should check is that if you have two connectors in a single remote network, both connectors need to be able to route traffic, not just one. Because remember that due to high availability, if you have two connectors in a remote network, you'll have about half of your clients that are going to connect through connector 1 first, and then connector 2 if connector 1 is down. But you have the other half that's going to connect through connector 2 first, and then connector 1 if connector 2 is down. So it's always a good idea to make sure that routing works from the perspective of both connectors. Now, that's if you have a resource that is based on an IP. If you have a resource that is based on a fully qualified domain name, user cannot connect to a resource that's at a fully qualified domain name. Again, the first thing you should check is, does the user see the fully qualified domain name in a client? If they do, are they using that fully qualified domain name to connect to the server, or are they using the IP? What I said about having an IP-style resource not intercepting traffic for the fully qualified domain name version of that same resource is true in reverse as well. If you have a resource that is declared for a fully qualified domain name, but not for the IP, and if a user uses the IP to, say, SSH into that server, that traffic is not going to get intercepted by TwinGate. So make sure the resource definition matches how users connect to things. If that's the case, so if you have the fully qualified domain name in the client of the user that's reporting the issue, then again, go back to the network events in the admin console and check for that particular resource if you see the inbound connection of the user. Now, one thing to note here is that the events you see here are not real time, they're near real time. So sometimes you'll have to wait a couple of minutes to see an event in here. You could monitor events in real time, and actually so in the documentations, there's guides on how to integrate your connector logs into a log aggregator. And there is a let me see, events in real time. This should give you a better idea of the types of information that you will get from those events. They're essentially exactly the same as what you saw here, except they're available in real time and in programmatic form through JSON. And so you can also ingest all of this in real time into something like Datadog, for instance. But what would be important here is to make sure that you see the events for this particular resource come in. And if the event comes in, inspect the content of the event, because there's most of the issues that happen here are that the connectors are not able to resolve server.corp.int, for instance, and therefore the DNS lookup at connector level fails, and so the connector just simply doesn't know where to go. Now, this is almost more true for Windows, right? Some Windows users are in the habit of not using domain names and just using host names. So that's also something that can happen if your users are using just the host names to connect to things. Make sure that, one, the client intercepts traffic for those host names by declaring a host name resource. So a resource that's just going to have the host name. Do make sure also that your connectors themselves are able to resolve host names without domain names. So what that means in reality is that connectors need to be set up with search domains so that they can automatically add a domain to search for a host name. That's more specific to Windows, but it boils down to the same thing. Connectors need to be able to resolve. So if you're using a fully qualified domain name, they need to be able to resolve the fully qualified domain name. And if you're using just a host name, they also need to be able to resolve just a host name. So make sure that it's true. And of course, both connectors also have to be able to resolve everything. Now, we mentioned this already, but again, you can rely on the admin console to do some troubleshooting and see if a user is having issues with their device or having issues with traffic. All of the events, all of the elements that are in a single event are also available programmatically, and we'll see that in a separate module around visibility. Now, there's more, so this is more of an advanced topic, and before we go to this, let's actually share a couple of things here that are also very helpful. If you need more troubleshooting than this, there is a self-serve, so actually you can just type troubleshooting in our help.twingate.com site. There's a self-serve troubleshooting guide that sort of covers what I mentioned here, but goes into the details of how to troubleshoot stuff on the client side, verifying port restrictions, verifying the client's able to connect to the connectors in our relay infrastructure, and so on and so forth. So it's all here. I highly recommend a read if you have an issue. In fact, you can rely on the Help Center for lots of those things. There's a lot of gotchas that will help you troubleshoot here. Now, if you're out of options and you've tried everything in terms of troubleshooting, another article that is here actually is how to get logs. So let's take a look at that. How to export Windows logs. Twingate client logs is the best place for that. Depending on the operating system that your user is using, you will be able to retrieve the logs of the clients that you can share with either a solutions engineer or support or on the forum to get a little bit more information as to why a client isn't able to connect. Sometimes there could be something like an incompatibility with another VPN provider or something like that. That's taking a look at the client logs is always a good idea. If you verified that connectivity can be established for a resource, but just not for a single user, usually there's an environmental cause to that, and looking at the client logs is always a good idea. Now, there's subtle ones that we should talk about as well. So remember that in Twingate, the way you declare resources directly dictates what traffic gets captured. That works well the very large majority of the time, because if you have a backend server that's at a particular IP address or that has a particular host name, you rarely have to assume that some of the traffic that is required for the application to work isn't going to go to that server itself. But that's not always the case. Sometimes a user will use a thick client, for instance, and this is particularly true of Microsoft stuff, it seems. But a user will be on Twingate, connected to the Twingate client, and try to connect to a backend through a fully qualified domain name. And you would normally assume that all of the relevant and necessary traffic gets captured by Twingate. For instance, if a user is going to work with Visual Studio, you would think adding a resource that's going to capture all Visual Studio traffic for the Visual Studio domain, which is visualstudio.com, is going to be able to intercept all traffic that is necessary for the application to work, and therefore you're all set. But for Visual Studio, it's not always the case. In fact, Visual Studio Code has a live share functionality, which allows developers to collaborate live. But it's Microsoft, and so Microsoft owns a lot of domains, including visualstudio.com, but they delegate some of the internal processes and communication to Microsoft.com domain or Windows.net domain. When that's the case, then it means that you have to also create resources for those additional domains to make sure that all of the traffic that is required for the application to run gets intercepted by Twingate. So in this case, if you know that Visual Studio Code is going to send traffic to visualstudio.com, but also Microsoft.com and Windows.net, and you only create a resource for visualstudio.com, then it's not going to work because some of the traffic is going to be bypassed and the application is not going to understand two different streams coming from two different places. So what you'll simply need to do in this case is you'll need to add two resources to make sure the right traffic gets intercepted for all of the domains here. There's a couple of things you can figure that out actually. So if it's a web application, you can usually see if your browser is communicating with the domain that you've created a resource for, but also with other domains. Like for instance, not that anyone would ever have to do that, but if you wanted to gate traffic to Reddit entirely, then creating a resource for reddit.com would be one thing. But if you take a look at any Reddit page, you will see that the page itself that renders in your browser pulls in images on a preview.red.it domain. So if you wanted to send all of your Reddit traffic to a connector, then you also should add a resource for red.it domain to make sure that gets in. So using the developer tools in your browser for web applications will typically allow you to see if there's domains that are not captured by the TwinGate resource, if there's domains that are called or connected to by the browser itself. It becomes a little bit trickier with a thick client because there's not often the equivalent of developer tools on a thick client. So what you can do in that case though is you can still do the same. Our recommendation, and when we've done in the past and can help you do actually, is to, if you see that an application is not functioning properly, even though you think you've created all the right resources, take a packet capture using something like Wireshark that's available on Mac, Windows, and Linux. So use Wireshark to take a packet capture to see what comes out of your client. Deactivate DOH or DNS over HTTPS if you have it, so we can see. So Wireshark captures your DNS queries from your computer to the application in the backend. And then once you've established connection outside of TwinGate, right? So don't turn the TwinGate client on, keep it off. Do what you normally do, connect to the backend application with Wireshark, and then take a look within the packet capture that you got to all of the DNS queries in that packet capture. We can help you do this programmatically, by the way. This will give you a list of all the domains that were connected to by your computer and that may not be actually captured by TwinGate. So for instance, if you actually go to the Lego website on lego.com and you run this process of doing a packet capture and then analyzing all of the domains that are queried by this request, you'll actually see that there's a lot of non-Lego domains. You have, looks like they use New Relic, for instance. Looks like they use Salesforce, and yeah, looks like they use Salesforce at salesforce.com. Now, again, not that you would ever need to intercept the Salesforce traffic for Lego, but it's looking at DNS queries in a packet capture sometimes allows you to see what traffic and what domains your TwinGate resources are not capturing. So it's always a good idea to do that if you're having those issues. It's a very niche issue. It happens almost never. Now, another classic one is, users saying that they can sometimes connect to a resource and sometimes not. That usually is because you have more than one connector in a remote network and not all connectors are either able to route traffic or resolve fully qualified domain names. So when that's the behavior, that should ring an alarm bell in your brain that if access is intermittent, there's probably something about connector load balancing that's not working right. So I would verify the configuration of both connectors. Yep, this one is a classic one as well. Look for issues on the connectors, make sure that the events are reflected in the admin console and go from there. This one's a classic one as well. We see this very often. I haven't verified a device in TwinGate, but it's able to connect to TwinGate successfully and connect to my resources successfully. There's a variation of that. That is, I created a profile in TwinGate that is supposed to verify my devices via Sentinel-1 or CrowdStrike. I don't have either Sentinel-1 or CrowdStrike on my device, yet I'm able to connect. That is always a question of how you've actually implemented your policy. The profiles you create, right? So if you go to the admin console, the profiles you create under devices security, the profiles and the minimum OS requirement settings that you have in your environments, they don't actually dictate anything about who's going to be able to connect to what resource and under which scenario. What you always have to keep in mind is, how is my policy actually defined? That is what determines what is checked. So if you take a look at the first policy, for instance, the first policy here is selected for only trusted devices. What that means is that this policy can only be fulfilled if the device you're trying to connect from has a corresponding trusted profile. So in this case, if only trusted devices is selected, it doesn't actually matter if your Mac has a screen log biometric configuration. It's still not going to be able to connect to a resource protected by the policy because it needs a trusted profile here, so it needs to be verified. If your policy says any device, then it's different, because if it says any device, it means that a device that has a trusted profile can get in, but a device that only fulfills the minimum OS requirements can also fulfill the policy. So in this case, it would be expected that a Mac OS that doesn't have CrowdStrike or Sentinel-1 can still get in, because this is the way in. And it happens also sometimes that customers will pick custom and then select a bunch of trusted profiles, but also minimum OS requirements. But the problem here is the same. You're essentially, by selecting custom, you're defining what ways a device can fulfill a policy. But if you're selecting, say, macOS for contractor, or macOS trusted here, and this, if you're selecting those three things, it means that devices that are not verified are going to be able to connect to your resources protected by this particular policy, because as long as they fulfill the minimum OS requirements, they will be able to get in. So just be mindful that you set your policies to check what they need to check. Otherwise, you're exposing yourself to a little bit of additional risk. And that often is the case, that policies are not implemented necessarily well. One that seems to also, that people seem to also hit often, is very specific to CrowdStrike, is that the CrowdStrike integration doesn't work. That is because CrowdStrike does not activate their functionality by default, and so you will need to reach out to their customer support. It's free of charge, of course, but you will need to reach out to their support team to ask for this feature to be enabled. You can actually verify if it's not been activated. The devices that have CrowdStrike installed are going to have a ZTA file at this location on Windows and this location on Mac. If the size of the ZTA file is 0, it means that the feature has not been activated by CrowdStrike, and therefore you will need to get in touch with our support to activate it. And this is, by the way, what you can communicate to them. What they need to activate is the CrowdStrike Falcon Zero Trust Assessment feature. That isn't activated by default, and there is, as far as we know, no way to activate it on your own. Troubleshooting for connector positioning. It's not really troubleshooting as much as it's just general recommendations. You should think of connector positioning as close as possible to your resources, but that doesn't mean that you can have a specific approach where you're going to have connectors in VPCs that are themselves peered to other VPCs with resources. You can absolutely do that. You can install connectors anywhere, whether on the same VPC as your resources or a VPC that is being peered to multiple VPCs with resources, or deployed on a transit gateway or transit VNets. All options are possible.